Now that I have all the parts made, I can start building the robot. I'm going to do File, New. So if you want to make a part, you obviously click Part because that's what you want. But if you're going to make something that needs more than one part, it's going to have a whole bunch of parts in it. Then you need to choose Assembly, and Assembly is something, just got multiple different parts in it, different components. And I'm going to call it 2013 Demo Bot. Okay. Alright. I'm just going to make a really basic, 4 wheels stuck on a frame type robot. To add parts to this, you click on the Assemble button. And this is going to add a part to your assembly. I'm going to scroll through till I find one of the channels. Not sure which one I want to use. When you're wanting to open a piece and you're not quite sure which one you want, you kind of want to get a closer look at them. You can change the view or whatever. Defaults to list. You can change thumbnails. That gives you a nice little sneak peek of what they look like. But if you want to get a closer look, you can click Preview, and that'll show you. Well, it's not right now. It's not really on a large picture of the piece, but you can control it like you would in Creo, and this kind of allows you to get a better idea of what the part looks like and how big it is. And I think this is going to be the base piece for the robot. Since this is the first piece, it really doesn't matter where it is. It's just up in open space. But this is going to be the default first piece I added for the robot. This is going to be the base upon which I'm going to add all the pieces. So what I want to do is go into this area. This is the constraints. What the constraints are is it's rules that the software follows to figure out where this piece is located at. Well, since this is the first piece, there's really nothing to constrain it to. So I'm just going to go in here. Right now it's set to automatic, and that really means it's just floating out and open. I'm going to change it to default. Now the piece has turned orange, and that means it's fully constrained. Alright, so first piece is done. Now I'm going to add a second piece. And it's going to be just like this one, same piece. Now we're going to get into how to move pieces around. What we got here is some weird little orb type thing, and it's got a whole bunch of different circles around it. These control the different directions you can move the piece in. In the middle here we've got a little ball. You can click on that and drag the piece wherever you want. And there's also arrows. You can use these to change the location also. What these circle things here do is they control the rotation of the piece. So using these, you can rotate them in any direction you want. You can turn them that way, you can tilt them, whatever you want. I find it handy when I open a piece. It's not completely necessary, but it helps if you kind of get it oriented in the direction and stuff that you want it to be attached to the robot in. So in my case, I'm going to have my base piece here. I think I'm going to have another channel just like it on the opposite side. And I'm just going to set this piece on top and then another one right there. So if I was building this like a normal robot, how I would do it is I would take a couple screws, put them through there, and attach them here and here too with nuts. But while you can kind of still do that in Creo, constraints and references are kind of going to serve as your screws while you're building stuff in Creo. If you want to add screws later for look or appearance, that's up to you. It's your call. But I usually don't, just because it takes quite a bit of time, and yeah, it's not really necessary. So I'm going to select this spot here. These are just the different holes. I'm going to select this by clicking on it. Then I'm going to go to the hole that I want it to be matched up with, and I'm going to click. Now what's happened is this hole, the first surface that I click, is matched up with the second surface. This is how constraints work in Creo. The first surface you click is constrained to the second surface. Now I'm going to do the same thing with the second hole, so I can have 2 points. And this is going to give it the direction. Now we have 2 constraints done. We have it oriented in a certain direction, but it can still move, it can still go up and down, and we want it to be fully constrained so it can't move at all though. So what we need to do is we need to click here and match that surface up with this surface. Now it's turned orange, and that means that it's completely constrained and cannot move. That's what you try. That's your goal. That's what you're trying to get to with every piece you add to this. Once I'm done, I'm going to click select, and I'm done with that piece. Now I'm going to repeat the same process again for the opposite side of the robot. I'm going to add another one of these pieces. And again for the second piece on the front of the robot. Now we've got the frame of our robot. Next I want to add some wheels, because wheels are really handy in a robot. They kind of, make it so it can move. First things first though, before I can add a wheel I need to add the motor, and before I can add the motor I need to add the bracket. So that's what I'm going to do first. The process of adding this is really the same as adding any other part. You just select the hole, then select where you want it to be matched up with. And I'm going to repeat this for the opposite side. Now that I've got the brackets on, I can add the motors. In Creo there are a number of different types of constraints you can use. There's coincident, there's parallel, there's normal, coplanar, tangent. The one used most often is coincident. What coincident means is the first surface you clicked is completely matched up and touching the second surface you clicked. Parallel means that it is obviously just parallel. And another one that's not showing up right now is distance. That's kind of like coincident, but it's just offset by distance. And another thing that you should probably be aware of is sometimes there's not really a flat surface on an object like this motor. If I wanted to make it so this was stuck here, there'd really be no way for me to do it since there's no flat surface for me to match up with another flat surface and make it parallel to. So what I do in this case is I can choose a plane, such as this one, and match it up with the bottom of this. And change it to parallel. Now the motor can no longer pivot and turn. Now to finish the constraints, I just click this surface and pair it with this surface. And what just happened here is for some reason it defaulted to it being matched up a really weird way, opposite, parallel, whatever. First off, I want it to be distance. And second, I want it to be the opposite way. I really don't want it that way. What this button does is it changes the orientation. So if I click it, it's oriented this way, and if I click it again, it's oriented the opposite way. Since I use the distance constraint, a number has popped up here, and this is the distance from the side of this motor to the edge of my bracket. I'm going to change this to negative, since I want it to be sticking out this side a little bit. I'm going to change it to negative 0.5. Select and done. Alright, so now as you can see, the motor has decided to turn sideways, and to be honest, I'm not really sure why it does that. It's really been an annoyance of mine. Whenever you click this surface, the front surface of it, and align it with something, it always deletes the orientation constraint that you've placed on it. And that's just one of the things that, since I'm kind of a newbie at CAD Creo, I'm not really sure how to solve that or remedy that. Really, the only way I know how to keep an orientation of a motor is not to get it aligned with the front face of this, which is obviously kind of annoying because then it's not fully constrained. But it's just one of those quirks kind of gotta live with, I guess. And it doesn't fully matter because this is just mostly meant to be a mock-up of your actual robot. So it doesn't need to be perfect and stuff. In real life, you turn it and stuff to get it lined up with how you want it. So I'm just gonna keep going and add the next motor on the other side now. Now that I've got everything ready to put on the front wheels, I think I'm gonna get the back wheels to the same point. And I think I'm just gonna use 2 Omni wheels hooked up to a small channel. So I'm just going to track down my small channel in this beautiful unalphabetized directory of parts. And I'm going to orient it in the direction that I want and attach it. Same way I did with the first bunch of channels. And that was not the surface that I wanted. So if you click a surface you don't want, you can just click undo and that'll cancel it. Very good. Now I'm going to do that same thing with the other side. For these rear Omni wheels, I think I'm going to create a custom assembly instead of just assembling it all right here. Just to kind of demonstrate how to create a custom assembly that you're going to insert inside of an assembly. So I'm going to do File, New, Assembly. I'm going to call it 2013 Omni Wheel. Okay. I'm just going to construct this with a washer. Actually, it's not called a washer. It's I don't know what it's called, to be honest. I'm just going to call it a washer. This is going to be my default, just like before. And I'm going to add a axle bracket. There it is. Alright, now I'm just going to click on this and then add that to this area in here, and that's going to align these two up. Now I'm going to click this surface, attach it to this surface. Now I'm just going to select, and then I'm going to add an Omni wheel. And last but not least, an axle. Alright. And I'm just going to click there, to this, set that to this, and there we go. It's all done. Now I've got my wheel assembly done. I'm just going to save, and I think that's, yeah. Alright, now that's done, I'm going to X out, and I'm going to add that assembly to my robot assembly. Awesome. And I'm going to do the same thing on the other side. There. Now both wheels are added. And from that, you can kind of see how useful making an assembly that you're going to use a number of times is. That basically cut my build time of those two wheels in half, which is really useful. Now I need to finish up the back two wheels by adding the stoppers and the two washers. Since this surface made it up with this surface, I need to do a change the orientation, and there we go, just how I want it. I'm going to do the same thing on the other side. Now I need to add the two stoppers, and the back wheels should be done. This constraint defaulted to angle offset, and what that means is this surface I selected on this stopper is offset by an angle of 270 degrees from this surface. And I don't want an angle offset, and I actually would want it to be a coincident constraint. And now that's exactly how I want it. I'm going to do the same thing on the other side again. Now the back wheels are done and in working order. Next I'm going to add the axle brackets to mount the front two wheels on. Now I can add the wheels. Now we got a robot with 4 wheels. Next we can add the fun stuff, such as sledgehammers and buckets. I'm going to operate the bucket off of a servo motor mounted in the front. First I'm putting on the mounting bracket. Next I'm going to add the servo motor in the bracket. Just kind of looking at the placement of the servo motor here, it doesn't look like I put it far enough out from the robot. So to change the position of the servo, I need to change the constraints. The model tree on the left has a list of all the parts in this assembly in the order that they were added. To edit the constraints, I find the piece that I want to change it for, right-click, and select Edit Definitions. Since I am editing the constraints of this piece, all the pieces whose constraints are based off this piece disappear. Now, poking out from this piece, there are a couple of different tags marking the constraints. I'm going to select the one I want to edit, then remove the reference that I don't want. Then I'm going to reassociate this hole with this back one. Now it's really off and messed up, but that's okay because I'm just going to adjust the second one too. Then I'm going to do the same thing as I did with that other one with this one. Now the bracket has been moved. Now I'm going to add a flat bracket and attach the bucket to it. Now I can add the bucket. Now we've got a robot with 4 wheels and a bucket for picking up blocks. So next I'm going to add our awesome little sledgehammer onto here. Now I think I'm going to do that is just put a bracket or two across and then mount it on with that. To power this sledgehammer, I think I'm going to use 2 DC motors. So I'm going to need to add 2 separate brackets, and I think I'm going to put them there, and then mount the motors to it. And as you can see, I goofed up. I didn't quite get the hole count right, so I'm going to have to move this a little bit. Now it's in the spot that I want it to be. Now I can add my motors. I know this motor isn't exactly lined up and, looks kind of awkward and stuff. But, like I said before, the idea of CAD is mostly just to make concept models of robots. So things don't really need to be exact. So I could, take this off and move it over a little bit or something. But, yeah, I'm just not really going to worry about it for the moment. Now I've got two nice little motors there. And the next step I think is going to be to add the hammer, and then actually after I get the hammer on, then I'm going to add the brackets. I think that would be the easier way to do it. There we go. That looks pretty nice. And I just need to add the brackets to hold it in place. These last two brackets that I added here and here, if you look at the side menu here, you can see that they've got this weird little square beside them, and also so does the sledgehammer. And what this square means is that it's not fully constrained. You saw when I accepted for these three objects, they were still purple instead of orange, and that means they weren't fully constrained. And what that means is they can still move around. I didn't add enough constraints to make them in a solid, non-movable spot. Oftentimes when you're working with motors, that's the case because this axle isn't actually fully constrained to the motor. It can't move in or out, but it can still spin. So, but yeah, that's the meaning of these little squares here. So if I would add another object to this hammer, like right here, then what I would end up with another square right beside that one. And what that would mean is I've got an unconstrained object hooked up to a non-constrained object, which is obviously bad. The ideal thing is for everything on this side to be constrained. Yeah, actually, like I got one here. This wheel is multiply unconstrained, and that's because I didn't hook it up to this bracket, right? Probably is what the case is with that. But like I've said a number of times, the idea with Creo is just kind of to add parts and get a basic concept for your robot, get some of the problems with your design out of the way before you actually take the effort of building it. So this is our robot. It looks pretty sweet. I actually wish I would have come up with this before we built our robot. No, just kidding. Ours is pretty sweet. And I'm doubting that a sledgehammer is legal for the game. So anyway, thanks for watching. This has been my CAD tutorial for what it's worth. I hope you got something out of it. Thank you for watching.